Hey guys, this video is for calculus and I'm showing this at the end of chapter 4. So this lesson is going to have content that you learned from chapter 3, derivatives, and chapter 4, integration. I personally like showing it at the end because these questions show how you can work forward from position to velocity and acceleration through derivatives, and how you can work your way backwards from acceleration to velocity and position using integration. So any given function is going to be the position function. Then when you do its first derivative, you get velocity, and then the second derivative would give you acceleration. So the way this lesson is called motion, and the way they're going to ask it is about a particle, and it starts moving, and what is its velocity, acceleration, when did it move to the right, to the left. And we're going to be hearing a lot of vocabulary that comes up in these questions, especially in the AP. And this first page is going to go over what all that vocabulary means, and then we're going to see a few questions on it. Okay, so always know that we're talking about motion moving along the x-axis. If we're asking about where it is at initially, we're talking about where the particle was at when time was 0, okay? And if you have a function in terms of x, that means when x is 0. When it is at rest, if they ever ask you when was the particle at rest, it means it stopped moving, meaning its velocity was 0. And if they give you the original function, you have to find the derivative, because remember the first derivative is velocity at 0. Okay? If they ask you when was the particle at the origin, that means its position was 0. That means f of x was 0. Okay? Now, if velocity is positive, meaning the first derivative is positive, okay, or the first derivative is negative, meaning the velocity is negative, we're talking about the particle moving to the right or up, okay? Ignore my writing for a second. And then if it's negative, it's talking about the particle moving left or down. If they ever ask you for it being furthest to the right, we're talking about a maximum, or furthest to the left, or furthest down, we're talking about a minimum, okay? Now, whenever we did our first derivative test back in chapter 3, we'd find when the first derivative is equal to 0, okay? We already said the first derivative equal to 0 is when it stopped, when it was resting, okay? And then when we did our number line, we'd test for positives and negatives. That is what I'm talking about here for velocity being positive and being negative, okay? And of course, A and B, your critical numbers, when that first derivative equals 0, is when you stopped, when you were resting, okay? Now let's keep moving on this way. So now, there are two different ways that I can ask for average velocity. Be very careful. The difference is based on what was given, okay? X of t is their way of saying position. Okay, so if they ask for average velocity and the position is given, you are doing slope, f of b minus f of a over b minus a. If they ask for average velocity and velocity is already given, then you're doing your average value, which we just learned in chapter 4, which was 1 over b minus a times the definite integral. Okay, so average value, position was given, you do slope. Average velocity, velocity was given, you do average value. Okay, if I ask you for instantaneous velocity, they're usually going to give you a time after that. What was the instantaneous velocity at 4 seconds in? You are doing the first derivative at that time that was given, and then you plug that in. Okay, if they ask, let's look at these two, for positive acceleration, very similar to what we were looking at up here. It's when the second derivative is positive, okay, and that means that velocity was increasing, which means that the first derivative had a positive slope, okay? Negative acceleration, second derivative is negative. We're looking for when the velocity is decreasing. So velocity implies that first derivative. Increasing and decreasing implies that second derivative, okay? Speed is the absolute value of velocity. So you find the velocity and then you ignore the sign, okay? Total distance traveled is the definite integral with the absolute value. We talked about this in our last video of chapter 4. Displacement and net change both mean a definite integral. Okay, again, we talked about that in chapter 4. And now these two wordings here, let's talk about this. If something is speeding up or slowing down, okay? Whenever they ask these questions, is the particle speeding up or slowing down? You need to find both the velocity and the acceleration, okay? If the velocity and the acceleration are the same sign, either both positive or both negative, then I'm speeding up, okay? If they were both positive, I'm speeding up in the positive direction. And if they're both negative, I'm just speeding up. Imagine if you put your car in reverse and go really fast backwards. I'm just speeding up in the negative direction if they were both negative. Now, if your velocity and acceleration are opposite signs, that is when you are slowing down, okay? And then just some more notation to reiterate the fact that original function can be written as f of x or x of t, because we're in terms of time, is position. Then the first derivative is velocity. And then the derivative of velocity, which is the second derivative, is what they label as a of t, which is acceleration. Let's take a look at this first question. It says that the velocity of a particle is given, okay? It's moving along a line at a time, t, when the velocity is, and they give you a function. How many meters? Anytime you see the words how many, we talked about that being keywords to mean to integrate, okay? How many, how much, how far, asking for quantities, total amounts. Did this particle travel from time 1 to time 8? Okay, so first thing we need to remember is that if I integrate, right, velocity, I'm going to get back to position. I want to know how much this particle traveled, so I want to know its position. So if we work backwards, the integral of velocity is going to give me position, okay? So now I'm going to say the integral, they said from 1 to 8, of that function, 5t raised to 2 over 3 plus 6t, and then our notation dt. All right. Next step, I'm going to do the antiderivative. Okay. Antiderivative here, my exponent is a 2 over 3. If I add 1 to that, I'm adding 3 over 3, so it becomes 5 over 3. So I have t raised to 5 over 3. Bring down that 5. Multiply by the coefficient, which would be 3 over 5. Okay. Now plus, if this t is to the first power and I add 1, it's now to the second. I bring down the coefficient of 6 and I divide by my new exponent, which is 2. And I'm doing this from 1 to 8. Okay. First thing I'm going to do is I'm going to clean this up a little bit. Notice that these 5s cancel. And I'm going to be able to reduce that 6 over 2. So I'm going to be able to say 3t raised to 5 over 3 plus 3t squared from 1 to 8. And now being that I have the same coefficient of 3, to make my arithmetic a little easier, I'm going to pull out that 3 and say t raised to 5 over 3 plus t squared from 1 to 8. And now hopefully that becomes a little easier. I'm going to bring this up, put that 3 on the outside, and now start with my function at b minus my function at a. And I put those extra brackets because if not, that would mean that the 3 is only being multiplied here. So for example, if I was on an FRQ, a free response question on the AP test, I could stop here. But if I missed that bracket, then it would only imply that 3 was being multiplied here. And even though I technically did everything right, my notation would give a completely different answer, okay? So for the sake of multiple choice and being able to match, let's keep going, okay? Whenever I have a fractional exponent, remember that the denominator is the root and the numerator is the exponent. Okay, so cube root of 8 would be 2, and then 2 to the 5th power is 32. 8 squared is 64. And then 1 raised to anything is just 1. So this is like saying 1 plus 1, which is just 2. All right, finish that off. We get 282, which gives me D. Let's take a look at this next question, okay? It says the position of the particle is given, right? So we have position, and it's given right here. Find the acceleration at 0. So acceleration would be the second derivative, and then we're just going to plug in 0, okay? So if this is my function, I'm going to go ahead and start off my first derivative. So x prime of t is going to start to give me my velocity. Okay, so here we have derivative of the outside. Derivative of cosine is going to give me a negative sign. Rewrite the inside times derivative of that inside. Don't forget chain. Minus derivative of sine is cosine. Rewrite the inside times derivative of that inside. Okay. Now to clean up my work, I'm going to put these as coefficients up front. And I'm just going to rewrite my work so it's easier to do the next derivative. Negative 3 sine of 3t minus 4 cosine of 4t. All right, so now I'm going to do my second derivative, which is going to take me down to acceleration, a of t. Bring down your coefficient. Derivative of sine is cosine. Rewrite the inside times derivative of the inside minus, bring down your coefficient. Derivative of cosine is a negative sign. Rewrite the inside times derivative of the inside is 4. And now let's clean this up a little bit. I'm going to move this 3 to the front like I did last time. Same with this 4. And now I'm going to have negative 9 cosine of 3t. Don't forget this negative I'm also going to take up. So it's going to be plus 4 times 4 is 16 sine of 4t. Now I'm going to solve. Remember, it's the second derivative at 0. That should be an equal sign, I'm sorry, which is going to be my acceleration at 0. So I have negative 9 times cosine of 3 times 0 plus 16 times sine of 4 times 0. Okay, well, 0 times anything is 0. So I'm really working with cosine of 0 and sine of 0 here. On my unit circle, make sure, please, if you're taking AP, you have that unit circle memorized like the back of your hand. At 0, my ordered pair is 1, 0, where this is my cosine and this is my sine. Okay, so cosine of 0 is 1, so I have negative 9 times 1 plus 16 times sine of 0 is 0, which cancels all of this out and leaves me with just a negative 9. Okay, and that makes my answer A. Question number 3 says, a particle moving along the x-axis with acceleration at any time t given as, and here's the equation, if the particle's initial velocity is 10. Let's talk about that word initial. We said that initial meant that time was 0. So what they're telling us here is that for velocity, we have an ordered pair of time being 0 and velocity equaling 10. Okay, now it says, and initial position is 2. That means for position, we have an ordered pair that when time is 0, the position is 2. And then it asks me, what is the position function? So here is where we're working with general and particular solutions. We're going to do the antiderivative twice to get from acceleration, then to velocity. Use this to find my C. and then over here to position and use this to get my c, okay? So let's start by getting to velocity. So if this is acceleration, v of t, velocity would be doing the antiderivative. So if my t was to the second power, now t is going to be to the third, and now I divide by 3. 3 divided by 3 is just 1. Next one. If my exponent here is a 1, now it's going to become a 2, and I divide 4 divided by 2 is 2. Plus, whenever I have a constant, it just gains the variable. And then don't forget to put your plus c. Now I'm going to use that ordered pair here and say that velocity at 0, I'm going to plug in 0. Is 10. Now, anytime they're talking to you about initial, notice that initial is going to cancel out every single term except for c, and you get what c equals, okay? So now I could say that velocity is, I'm going to rewrite here and just put the 10 in the place of c. T cubed plus 2t squared plus 6t, and I found out that c was 10, so I'm just going to put plus 10. And now I can keep working on to position. So notice that was the end of velocity. When I get to position, I'm doing the antiderivative again. If my exponent was 3, now it's going to be a 4, and I'm going to divide by 4. If my exponent was a 2, now it is a 3, and I'm going to divide by 3. If my exponent was a 1, now it's a 2, and I'm going to say 6 divided by 2 is 3. Any constant gets a variable t, and then I have to remember plus c again. Now I'm going to plug in my initial condition right here, plug in my 0. And hopefully you can notice that what I'm writing right now is technically a waste of time, because I told you anytime that time was 0, my c is just going to equal that number. But I'm going to write the workout for you. No. Sorry here, trying to go too quick. Equals 2. So you can see that all of these cancel, and you get that c is 2. So you are looking for a function that says 1/4 t to the 4th. And I hope that as you start going through this, you start taking a peek at your multiple choice, because in an AP test, if you can figure it out faster, you don't have to show all this work. They don't check your work on multiple choice. Okay, so already I can eliminate this one and this one. And then plus 2/3 t cubed, 2/3, 2/3, 2/3 t cubed. And then plus 3t squared, 3t squared, 3t squared, 3t squared. Then plus 10t. This one doesn't have the plus 10t. This one does. And this one does not either. So far you can already see that your answer is B and you haven't even finished, okay? But I'm going to plug in my C and put plus 2. And that's my final answer, leaving me with B. Let's go ahead and move on to number 4. All right, number 4 says, if the position of an ant traveling along a horizontal path at time t is given here, what is the ant's average velocity? So they're asking for average velocity, and they're giving you position. Be very careful. Most people will do average value, but they're giving you position, which means we are doing slope from 1 to 6, okay? So if my position, we'll call that S of t, we can call it X of t, they put many different variables for that, is 3t squared plus 1, we're going to do slope, which would be S of 6 minus s of 1 over 6 minus 1. Okay? Now, if I plug in my 6 into s, which is up here, 6 squared is 36 times 3 plus 1, that's going to give me 109. And now if I put s of 1, which means I'm plugging 1 into my function of s, then I'm doing 1 squared times 3 plus 1, which gives me 4 over 6 minus 1 is 5. And if you clean this out, you get 105 divided by 5, which is 21. For this next question, there are two ways to solve it. Okay, and I'm going to show you both. It says a bottle rocket is shot upward from a 10-foot stand. That means when it was first shot up, it was already 10 feet up. So this is your initial condition. This is when time was 0, okay, my height was already 10. Okay. Now they also tell me that it has a velocity with this given function. What is the position? So I'm going from velocity to position, so I know I'm doing the antiderivative of the bottle after 2 seconds, okay? So method number 1 is to say I was initially 10 feet high, so I have to take that into consideration. And then I have to add the amount that I changed from 0 to 2 seconds of that function of velocity. Okay. Method number 2 is to say, okay, I'm going to do the antiderivative and get from velocity to position. So my position function, we can call it x of t. A constant gets a variable minus that t is going to be to the second power. And now I'm going to do 1.6 divided by 2, which is going to give me, negative, right? Negative 1.6 is going to give me a negative 0.8, 0.8. And then don't forget your plus c. And now I'm going to use my initial condition, x of 0. When my position is 0, it should equal 10. Okay? And if this cancels out, that means c is 10. Put the 10 in the place of the c. And now using this full position function, find it at 2 seconds. If you plug that into your calculator, you should get 106.8. All right, which leaves you with answer E. Now, if I do the same thing over here, I'm going to have 10 plus, do the antiderivative, and notice, guys, that when I plug in a 0 into here and here, it's going to cancel everything out. So it's like I'm saying minus 0. Okay? So before I even finish, so your eyes can start catching, notice that in both methods, I'm technically have the same work. Here's the 50 times 2 minus 0.8 times 2 squared, and then here's the plus 10. Okay? It gets me the same exact answer. Two different methods of writing it. Same thing. If this was a calculator question, I would suggest this left one. And I just noticed you can't see the 10. I would suggest this left one because you can type all of this in at once into your calculator and it'd give you the whole answer, okay? Let's take a look at the next one. This question is also pertaining to the same information about the bottle rocket from number 5, and it'll also continue on for number 7. And it says, when will the bottle rocket hit the ground? Okay, so if we're talking about hit the ground, let me draw you a little visual to see if it helps you understand. Remember, no, let's see if I say that's y and that's x. All right, this is y and this is x. Remember, we started on a platform 10 feet up, and they shot the bottle rocket, and it's eventually going to come back down, right? And what I want to know is, when did I hit the ground? Okay, so hit the ground is asking when the position of this bottle rocket, right? It goes from 10 feet high, the position, then it shoots up, and it'll eventually come back down and hit 0. So what we're asking is, when is the position equal to 0? That's what I'm asking. Now notice in this previous question, we already did the work of finding the position function, okay? Because if you use the equation that was given at 50 minus 1.6t, you're technically using the velocity. And if you do it that way, the work you'll do will be wrong, and they'll even have the wrong answer in there, which I'm going to point at this one in case you do it wrong really quick. So I'm going to get that. I'm going to show you two versions on how to solve this. We are obviously saying that the position, right, which we wrote was 50t minus 0.8t squared plus 10 equals 0. Okay? Both versions are going to be with your calculator because this is obviously a very messy quadratic function. So option 1 is with the graphing tool. Okay? So if you are on your graphing tool, here's option 1. You are going to type in x of t into y1. Okay, and I'm going to show it to you as we do it. Right? I plugged in x of t into y1. Then you're going to change your window. Okay, and if I look at my multiple choice options, time is going to be on my x. My smallest is 0 and my biggest number is 62. So I'm going to put my window like from 0 to 65. Okay? So when I graph it, I see this blue line. I go have from 0 to 65, and this function is shooting all the way over here, which probably tells me that my answer is either D or E. Okay? Now I'm going to click second cal 0 to confirm. Okay? So second, here's cal, and then 0. And it's going to ask me for that left bound and right bound. You can literally type in 0 to 65 and then press enter. And it's going to find it because there's only one time that it hits a 0. And you get 62.699, leaving you with answer E. Okay? Option number 2, I'm going to suggest that you get really comfortable with the graph if you're an AP, because that is used very, very often. But option 2 is going to be quadratic formula. Because a quadratic formula would solve when this function equals 0. So you have negative b, be careful because it's in out of order, right? This would technically go first. So this is your b, a, and c. Plus or minus square root of b squared minus 4ac all over 2a. Okay, now when you plug that into your calculator, I've already typed it in to save some time. I type it in once with a plus and once with a minus. I get both of these answers. Okay, you always get two answers from the quadratic formula. Now, we're measuring time since I shot off the bottle rocket. Time is only moving forward. We cannot travel back into time in negative time. So anytime we get a negative answer with respect to time, we're not going to talk about that. We're only looking at that 62.699, reiterating that my answer is E. All right, let's go ahead and move on to question number 7. It says, after 3 seconds, the rocket is falling at an increasing rate, rising at an increasing rate, rising at a decreasing, falling at a decreasing, or rising at a constant, okay? So this is like that speeding up or slowing down type question, okay? Falling and rising is going to be a positive or negative velocity, and an increasing or decreasing rate is whether my acceleration is positive or negative, or if it's at a constant rate, it would be 0, okay? So my first step is going to be to find my velocity at 3, okay? Velocity was given at the very beginning of the question with that 50 minus 1.6 t. So velocity at 3 is going to be 50 minus 1.6 times 3. Now, if I don't even have to put that on my calculator, I know 1.6 times 3 is definitely not going to be bigger than 50. So 50 minus a smaller number is going to give me a positive, which means that it is rising. If velocity is positive, it is rising. So I can cancel out falling and falling. Okay. Next step is to find acceleration at 3. That's going to determine the increasing or decreasing rate. Okay. So acceleration, I have to take a moment and solve for the actual acceleration function. I don't have it yet. Derivative of 50 is 0 minus, remember this is 1.6 t, so it's just going to be, the derivative of that is 1.6, okay? So if I do acceleration at 3, no matter what number I put in here, I'm always going to have a negative 1.6, okay? Which means that it is negative, which means it's at a decreasing rate, okay? Which leaves me with letter C, rising at a decreasing rate. So one more time, if the function is moving up, down, left, or right, we talked about at the beginning, that's velocity being positive or negative. So that was the falling and the rising. Now, the rate that it was doing that, it's the next derivative. It's whether it's accelerating or not. Positive acceleration is at an increasing rate. Negative acceleration is at a decreasing rate. Question number 8 says the position of a particle is traveling along a straight line, and it's given by this function. On the interval from 0 to 10, when is the particle furthest to the left? Okay, we said earlier that furthest to the left meant that we are looking for the min. Okay, if we're looking for the min, this is like an optimization question from chapter 3, and we're going to have to find the first derivative, test our intervals. So let's get started on that, okay? To begin with, x prime of t is going to be 3t squared minus 18t plus 15, okay? We set that equal to 0, and in order to solve this, I'm going to have to factor it and say 3t times 1t, and then 3 and a 5, and a negative and a negative. Negative 3 times negative 5 is going to give me a positive 15, and a negative 3 times a negative 15 is going to give me a negative 18, which means that my t here, if I move over, I add the 3 and divide the 3, is going to give me 1, and then positive 5, okay? If I put those on my number line, remember I am checking between 0, I have 1, I have 5, and then up to 10. Okay, so now it's time to check my intervals. So now I'm going to check, let me draw a line here so we don't get that mixed up. Let's try a number here, it'd be 1/2. If I plug a 1/2 into my derivative, always use this factor one, it's going to make it a lot easier. Half of 3 minus 3 is going to give me a negative times half minus 5 is going to give me another negative. A negative times a negative gives me a positive, okay? Which means I'm increasing here. Let's pick an easy number here. Let's do 2. 2 times 3 is going to be 6 minus 3 is going to give me a positive. 2 minus 5 is going to give me a negative. A negative means that I am decreasing, okay? And then lastly, let's try a number in here. I'm going to try 6. 6 times 3 minus 3 is going to give me positive, and 6 minus 5 is going to give me a positive. Positive means I am increasing. So because I'm including my endpoints, my possible minimums, I started down low and went up. This is going to be a min. This is going to be a max. I went down and then I'm going up, so this is going to be a min. Here's another possible one. And then this is going to be, I went up and I stopped. This is going to be a max. So that means now that I need to test between 0 and 5, because notice that 0 and 5 are options, right? I can cancel out. 3 didn't even come out as a critical number. And 1 and 10, I'm sorry. These are going to be maximums. So be careful not to go straight to 5. Make sure you remember to include that endpoint. Now I have to plug them into the original to see who truly has a lower value. So my original function is here. X of 0. This one's very easy to do because 0 cancels out anything that has a t. It's just going to give me 3. And then x of 5, if you plug that into your calculator, you get a negative 22, which means that this is the lowest. This is my min. All right, we're going to skip number 9 here, and we're going to work our way down to number 10. All right, when two particles start at the origin with velocities, here's the first particle's velocity, and here's the second. Be careful here, how many times, it doesn't say when, it says how many times from 0 to 2 pi will their speed, remember speed is the absolute value of velocity, be equal, okay? So if I want to know when their speed is equal, I want to say if this is the velocity of the first one, I'm going to say absolute value of 4 cosine of t. When is it going to be equal? How many times will their speed be equal? So I'm going to say equals. Now the speed, which is the absolute value of this one. Okay? Since they each have a coefficient of 4, I can divide out the 4 and ignore them. And I'm literally saying when is the absolute value of cosine equal to the absolute value of sine? Which means when are sine and cosine equal to each other without counting the signs being positive or negative from 0 to 2 pi? Well, on my unit circle, I know that at my pi over 4s, I have those identical ordered pairs of radical 2 over 2, right? I have one here at pi over 4. I have one here at 3 pi over 4 where the cosine is negative, but again, we don't care about that because of the absolute value. We have one down here at 5 pi over 4 where they're both negative. And then again, this goes back to just having that unit circle down packed. And then here at 11 pi over 4, we have the sine is negative. So if this would have said when are their velocities equal, we would have said twice. We would have said here when they're both positive and here when they're both negative. But because it says speed, it says that we don't care about the sign, so I can count all 4 of these spots. And the fact that it said how many times leads me to my answer being 4.